Projection when particle projected from height at some angle with horizontal. Here, particle is projected from a height h at some angle theta with the horizontal. What will be the time of flight? What will be the maximum height from horizontal surface? What will be the range? How we are finding? To see here. Here also we have to take two motions, horizontal and vertical. For horizontal motion, we can see horizontal motion u has two components. Horizontal component will be u cos theta. If we go for the vertical component, so you can see here vertical component will be what? That will be the u sin theta. You can see uy is equal to u sin theta and ux is equal to what? This is u cos theta. So horizontal component, initial velocity ux is equal to u cos theta. Since no force is acting, that's why acceleration is 0. When we will talk about the vertical component, for vertical motion, we can see here for vertical motion, initial velocity ui is, see here, in this o I have taken origin. This is x-axis, this is y-axis. I have taken upward positive and downward I have taken as negative y direction. Upward I have taken positive, to initial velocity ui is equal to plus u sin theta. Downward I have taken motion is negative, that's why acceleration, vertical acceleration, it is downward, hence it will be negative, that will be minus g. You see, for time of flight, this is the initial position when it will touch the ground. So what will be the vertical displacement? The vertical displacement from origin is h. This will be the horizontal plane at O. This is the ground. Vertical displacement. So this will be the vertical displacement downward. Since it is downward, you have to take negative. So vertical motion. Vertical motion. Displacement, vertical displacement is minus h. Initial velocity is u sin theta. Acceleration is minus g. And t is time of flight. So what will be the time of flight? From O to ground. This y is equal to what? Uy half ay t square minus h u sin theta t, here t, capital T, ay minus g, so this becomes minus gt square. If you are taking this left hand side, so half gt square minus u sin theta t minus h is equal to 0. So from here, this will be the quadratic equation. By this quadratic equation, we can find the time of flight. T is equal to minus b plus minus under root b square minus 4ac, 4ac, c is minus h upon 2a. So that is 2 into half g. Negative sign we have to leave. If t will come negative, suppose t come plus 6 minus 2, so plus 6 we have to take, minus you will leave. So by this method we can find the time of flight. So same thing you have to do. What we have taken in the horizontal projection, or we have taken projection from ground at some angle. So this same theory we have to apply for the projection from some height. Only thing is there, the vertical displacement If object is projected from ground, vertical displacement we are taking for time of flight 0. Here vertical displacement we have to take minus h. So by this method we can find capital T, mean time of flight. If I want to find range, how we are finding range? Where the distance from vertical wall where it will fall, horizontal distance. So horizontal range mean this distance. If this A, suppose ground where this pillar is, that is B, so you want to find BA. So horizontal range BA is equal to what? Horizontal velocity, no acceleration is there, horizontal velocity into time of flight. So horizontal velocity into time of flight. Horizontal velocity, constant horizontal velocity, that is u cos theta into time of flight, you have to find from this equation. So this will be the horizontal range. If I find maximum height, the position from the horizontal ground, what will be the maximum height position for this projectile? So we can find, suppose I have taken this horizontal projection from ground. Suppose I have taken this as a ground and an angle theta. So I can find this height h dash by the general formula, and this h given the total this h plus h, we can find total height h from the ground. So this h dash, how can we find? Velocity of projection is u, angle of projection theta. So what we know, if projected from ground, what will be the maximum height formula? That is u square sin square theta upon 2g. By this method I can find h dash, and this h from where it is projecting. This h plus h dash, this will be the total height or maximum height from the ground, or maximum displacement from the ground. What will be the maximum height here? Total maximum height h dash plus small h, or you can say u square sin square theta upon 2g plus h. This will be the height, maximum height from the ground. And if you want to find velocity at any instant, so see here, if you want to find the velocity at any instant, same thing we have to do. What happened? Horizontal velocity, it will be always u cos theta. Velocity at any point, what will be the vertical component? By this method we can find here. So see here, horizontal component will be u cos theta, vertical component v is equal to vertical motion we can find. So if we'll see for the velocity at any instant, so see here, velocity at any instant, horizontal component will be u cos theta. If we'll go for the vertical component, v is equal to uy. The initial velocity is u sin theta plus ay. Ay is g, time is t, ay gt. So horizontal vertical component, if I find it, so what will be the velocity at any instant? Vx square plus vi square. So this will come under root u cos theta square plus u sin theta minus gt square. By this method we can find velocity at any instant. If you want to find the angle at which this make with the horizontal, so this will be the vy upon vx. Vy mean u sin theta minus gt upon ux. Ux is u cos theta. So this will be the angle phi which it makes from the horizontal. The same thing we have to do. Vertical projected fin from some height at an angle theta, we can find time of flight, horizontal range, maximum height from the ground, and also velocity at any instant.